So next would be this table shows the calculations for film coefficients. So this side is for the gas and this side is for the air. So these are the how to solve the overall U. So a check on original assumptions of 83 degrees drop on the gas side is next made by equating heat transfer to heat release. Log MTD and total heating surface are required. So theta max, theta minimum. So total surface, this is how to solve the theta max and the theta minimum and the theta. So total surface of 33,576.2 millimeters diameter times 3.66 meters cube is 30 to 66 meters squared. So the following are the formula. So 3,600 W sub G C sub G delta T is equals U A theta. So equate deriving the formula theta now is equal to plugging in all the givens, so which is equal to 95.4 degrees Celsius. Next would be the recuperative air preheaters are generally enclosed in rectangular sheet steel casings. So the recuperative type may be composed of steel tubes from a diameter of 50.8 to 76 millimeters. So this is the standard diameter. So in parallel bank or alternately of rectangular flat plate space from 12.5 to 25 millimeters apart, leaving the alternate air and gas passages. So this figure shows the regenerative air preheater. So it has a gas outlet here, air inlet. So this is where the air flows, and this is where the air out. So it also has a gas inlet here and the air outlet below. So draft. So combustion requires oxygen and therefore air to move this air through the fuel bed and to produce a flow of the gaseous products of combustion out of the furnace, then through the boiler, economizer, and etc. Requires a difference of pressure equal to that necessary to accelerate the gases to their final velocity plus friction head losses. This difference of pressure is called the drop. So whether measured above or below atmospheric pressure. So the draft is the is the difference of pressure. So that is what we call draft. Next would be the figure shows the typical pressures in the gas loop. Next would be the apparatus for velocity transverse and static pressure with a single manometer. If the duct carries a plenum, the leads to the manometer are reversed. When the static pressure exceeds the capacity of the sensitive manometer, a YouTube manometer is added as shown. So this figure shows the draft loss fuel beads. So for some purposes, the draft pressure must be used as grams per cubic meter or kilograms per cubic meter. To convert a draft gauge reading, multiply the gauge reading in centimeters by the density of water in grams per cubic meter to obtain the pressure in grams per cubic meter. So that is the way on how to convert drop gauge reading. So it frequently happens that the gas flow is slowed down and a pressure built up or vice versa. The equation used to relate the pressure increment to to gas, velocity is derived from Bernoulli's principle, assuming incompressible flow. So v sub 2 squared minus v sub 1 squared is equals to c squared times 2gh, where v1 and v2 are the gas velocities before and after applying a driving pressure of h in meters of gas. So C is the velocity coefficient, generally nearly unity since gauge readings in centimeters of water rather than meters of gas, and conversion is necessary. So gas conduits. These conduits connecting the various pieces of equipment of the gas loop, thereby providing a passage for the gas or air as it flows from one to the other, are either ducts or breachings depending on whether air or products of combustions are conveyed. The term flue is sometimes used interchangeably with breaching. So breaching is also known or also called as flue. So air ducts. So the design of a duct is a compromise between first cost and cost of energy loss from the friction. This means a compromise between cross-sectional area and velocity. So next would be the table, the recommended velocities in air ducts. So these are the static pressure, velocity, static pressure, and velocity. So breaching. So velocities in breachings are not usually made less than 6 nor over 5.12 meter per second at rated flow. If possible, the gas should be made to flow with approximately the same velocity as it has in the preheater or economizer. So, the gas passages of modern plants offer many variations that little may be said that in a way of generalization. A breaching as such is often practically non-existent, while auxiliary heat-absorbing surfaces have occasioned almost as many variations of gas pressure design as there are units, which in some cases are serviced by individual stakes. Some of the devices employed today, all of which must be incorporated to the flue gas circuit between and stock if they are installed are first economizer, air preheater, induced draft fan, and dust collector. So this figure shows the location of draft measurements. So the following are the draft measurements. So next would be the heat loss through 85% magnesia insulator having 12.7 mm asbestos cement finish. So we have here an insulation thickness millimeters. We have here the temperature difference hot surface to air degrees Celsius or degrees Fahrenheit. So problems to be met and overcome by a breachings are numerous, but apparently corrosion is one of the most troublesome. So there are some problems that breaching the breaching must overcome, but the famous or the the most um the most damaging one is the corrosion. So the proper design of ducts and breaching should include provision for A. Expansion, B. Insulation, C. Support, and rigidity. So we have some provision here for the proper designs of ducts and breachings. These four should be followed. So draft by fans. So mechanical draft fans have an important place in engineering of power plants. Without fans, the high rates of heat transfer now possible could not have been realized, nor would the thick fuel beds of underfed stokers have been possible. So mechanical draft may be classified as forced or induced. So the fans is a important part of engineering of power plants. So The picture shows the formula of work added to the air, so kilogram meter per kilogram. So this is the W, and this one is the specific volume of air, gas, delta P, static pressure increase. V sub 2 and V sub 1 is the velocity. So this is so these equations are derived until here. So next would be the figure of basic blades parts for fan wheels. So this one is the backwardly curve. This one is forwardly curve. So backwards, so it means clockwise. I mean counterclockwise. And this one's is clockwise. So forward curve in the radial. It seems so equally. It has some equal sides or some wheels. So next figure would be the installation of two motor-driven induced draft fans. So fan tests are seldom performed by the plant engineer unless as acceptance tests. Then pilot static equipment is generally employed, and there should be some provision for the test openings. Experience indicates the velocity in widths and reachings varies across the flow, so that the area should be divided into elements. Rectangular sections are divided into small squares and readings taking at the center each. Circular ducts are divided into equal area rings, and test stations are set opposite mid-radii of each. So chimneys, so whether to produce draft by fan or chimney may be an open question. This is necessitating a complete comparison of the characteristics of each before an answer can be given. So evolution of chimney action. So D is the height times the difference. D is equals to the height times difference in density of flue gas in air. So this is the evolution of the chimney. From here, it is a new shape, and this one looks like a parallel. This one is also like a like Q, but it has a square edges here, and here from it looks like a cylinder, and from here to here. So next would be the masonry chimney. So this is how it looks like, the masonry chimney. And wait, combustion control equipment. So combustion control systems consist of the following elements. So these are the elements of combustion control systems, and this is how it looks like. So next would be the remote positioning control and arrange for two spreaders to occur, boilers, valves, drains, filters, and gauge omitted. So as the detail of construction of various units with the manufacturers assembled control systems to meet the individual owner's needs are almost innumerable, and as they are constantly in the process of development, only a few of the principles of the mechanism are shown in accompanying figures. For further information, the reader will need to consult manufacturers' bulletins or specials. So it must have a provision of specialists, or the one who is skilled enough for this matter. So that's all. Thank you.